Good evening. Let me make sure the microphone's working here. Perfect. Okay. Welcome to another exceptionally late Code Kata. It's about 12:30 a.m. here, so we're going to try to make this really quick. We're going to be looking at some 6 queues. We're sorted by most completed. So let's see what we got here. Multiples of 3 or 5. Sum of digits, a digital root. Words spinning. Stop spinning words. Stop spinning my words. Oh, every other word gets reversed. Bit counting. That sounds kind of fun. Create phone number. Sounds counting duplicates. Playing with digits, very vague. Let's find out. Decode the Morse code. That sounds fun. Alright, let's look at those 3. So, first, bit counting. Write a function that takes an integer as an input and returns a number of bits that are equal to 1 in the binary representation of that number. Okay. Returns a number of bits that are equal to 1. You can guarantee the input is non-negative. Binary representation of 1, 2, 3, 4. So the function should return 5 in this case. 1, 2, 3, 4, 5. Very cool. A little bit of math there, not much. Some numbers have funny properties. For example, 8 to the power of 1 plus 9 to the power of 2 is 89 times 1 is 89. 6 to the power of 2, 9 to the power of 3, 5 to the power of 4 is 1,390. It's equal to 695 times 2. Okay. I'm not sure. I don't think I want to do this one. Okay, this kata is part of a series on Morse code. After you solve this kata, you may move to the next one. Oh, interesting. That sounds very fun. I think I'm going to save this series. Let me bookmark this. Kata Morse series. And we can do that on stream as a whole series. So, I think it's bit counting. Okay, let's train on this. So, first thing, I'll pull in my tests. Okay. So we're going to make a directory, and the directory is going to be bit counting. This right here. There we go. Bit counting. And then we're going to touch kata.go and kata test.go. And we'll do our test first. Paste in what we have here. Anybody who's watched the stream before knows that I changed these tests a bit. I make the package the same and I import testing. Do that in every single one. We'll always do that for the foreseeable future. Create a variable for my bit what's this folder? Oop. Bit counting. Bit counting tests, and that's always a struct, a slice of structs, right? And the in of these is going to be what? A uint, an unsigned integer. So let's look at Golang. Int types. I think we can do that. We have a uint here. Do they specify? They don't specify. I'm going to make it a 64-bit uint. So I'm going to do uint 64. uint 64 I do that because I don't want to worry about like integer overflows in a 32-bit integer in case the tests have like obscenely large numbers, just in case. And we'll test that boundary and see if that's necessary. And then we want to get back an integer, so we'll just give it an int. Right, and it's just going to count up binary numbers, so 32-bit would probably be fine there. Probably could do 8-bit, etc. Okay, so inside of our initialization, we're going to have a number, doesn't matter which, so in their case, 0 returns 0, and we do that 4 times. Okay, and this will be 4, 7, 9, and 10. Oops. 10. 10 returns 2. 9. Oh. 9 returns 2. 7 returns 3. And 4 returns 1. So we create a func test bit counting. Bring in t from testing. And for the test in the range of our bit counting tests. At this point, I like to edit my kata.go and paste in what they'd like. Okay. I always give this a default value, so I'm just going to return 0 for now. And then the result is going to be equal to count bits, the count bits function. Count bits, and we pass in our test.in, which is a uint, and from it we get an integer. So if our result does not equal our expected test output, we have an issue, and that issue will be formatted error from our uint. We expected our result. In fact, yeah, that's right. And we got a different result. Yeah. And so from test.in, we expected test.out, and we got result. Okay. Which means we can get rid of these, and we can run this test. CD into our bit counting and go test. Right? And so we see undefined uint64. Oh, this is my bad. I have a typo. uint. There we go. Okay. Cannot use 64. Oh, so it's expecting just uint. So we just have to go with that. Okay, so perfect. So we can see here on our tests that from each of the inputs that we gave, we expected an output, and we got 0. And the reason that we got 0 is because we told it to return 0. So now we have to work on this. So first thing we have to do is convert a uint to a slice. Basically, we could do a couple of things. We could just convert it to an int representing the binary of the integer, right? So we have to think about how we get the binary. So what is binary fundamentally, right? So there's binary is 8 bits representing a so I'm trying to think about how to explain this, but picture this. You've got 0, 0, 0, 0, 0, 0, 0, 0. And those are going to be from this end, right? We've got 1s, 2s, 4s, 8s, 16, and then from here on out, you get a little extra space. 32, 64, and 128, right? Yep. Okay. I think I did that right. So all right. So the maximum represented in a byte, byte, 8 bits. So 8 bits known as a byte, representing the value of an integer. Say something like that. Maximum amounts of byte is 128 plus 64 plus 32 plus 16 plus 8 plus 8 plus 4 plus 2 plus 1. Alright? And so if you did like quick maths, 128, 64, 32, 16, 8, 4, 2, 1. And I guess we have to run that. Oh. We'll just go to our calculator. It should be 255. So let's do that. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 255, right? And this is like where you'll see RGB colors in CSS. It's because it's all contained in one byte. All right, so equals 255, which is to say that 1 in binary is 1, 2, 3, 4, 5, 6, 7, 8. All right. So how do we convert to binary? And let me go back to the challenge and make sure we're reading this right. Write a function that takes an integer as an input and returns a number of bits that are equal to 1 in the binary representation. So I'm just going to say Golang int to binary. I don't want like a cheater answer. I don't want them to do the conversion for you. Right, this is more, okay. Format int, all right, so on string convert, strconv Golang and we just search binary. Format returns a string representation. Is this what we wanted? Nope. Format int. Yeah, format int. So let's try that out in the playground. Format int 1. Oh, this guy has a lot of code. And then we string convert it, fum to print it, and we run it. But returns one value. Not enough arguments in format int, so string str conv Golang format int. Format int base 10, right? So formatting returns a string representation of I, so base 1. Okay. Format returns a string representation of I in the given base for 2 base 36. What's this do? Okay. Try that again. Golang int to binary. Check out the binary package. They just say format int 2, which does not seem to work. But let's try again. Play.golang. Right. strconv. Okay, well there they go. What did I do differently? Format int. Format int. Let's do this. Is it the type? Okay, so let's mess with types, right? So we do this, and we'll just say A is equal to an int 1, and we take A, int as type int 64, requires int 64. Run. Oh, but we print line. It's no different. So fumpt print line D. We'll say F. and we just put this to F. What is different? 1, 1. Oh. Okay, so 2 would be 0 or 1, 0. Oh. Okay. All right, so we'll do that. We'll bring in our string convert, import strconv, and basically we just say, can we have an int of a size? Int 8. Ooh, let's try that. So how would I do that? Var f int size 8. Unexpected. Golang specify int of size. It's not really even a size. Like Golang add zeros before int. I don't want to funct print it. I don't want to sprint it. That's an interesting idea. So with this, okay, so you can't fundamentally, right? Then that makes sense. So it'll never have zeros over here, and it can't without being a string, which is why we're going to count from the right to left. Actually, we just count it. Just do that and count it. Okay. Duh. Uint is equal to string convert format int, pass in uint, and then can we range over a number? So like for index value in the range of f bumped print line value. Yeah. Yep. I wonder if we do index and then we do f at index. Okay. Okay, so that's, and now that's the ASCII character. So it's like we'd have to convert it. So right, so string of value. There you go. What happens if we do int? Okay. So Golang iterate over integer. iter.in. Oh, somebody's got a package. Oh, thank you. If we say Golang int range 1 is 49, I think it was. Well, so like ASCII table. Yeah, so here it is. So 49 on the ASCII table is 1. So we want Golang ASCII code to int. Oh, right. So it's A to I, ASCII to integer. So it'd be string convert at A to I value run. Cannot use type rune as type string. Okay, so ASCII string conversions. ASCII, quote to ASCII. No, not really what I want. Like how to convert ASCII to convert character to ASCII and back. That's the thing. Is like, like what type is this then? Print the type of value. Golang get type. Type of. We need reflect. Import reflect dot type of value. Int 32. But the int 32 is being like how to compare ASCII int to regular int Golang. I mean, I could do this very int value to string. I don't want to do that. Int to string. I don't want to do that. Byte to int. So like, what's the type of? Let's do this. Integer is equal to an int. We'll just say equal to 1, and then we print I reflect not type of I value and reflect value int 32. Okay, so we say var I is an int 32 that's equal to 1. See if that works. Int 32 equal to 1. Okay. You see where the problem is? So when we range Golang get each integer in a number. first three. No, no. Count number of digits now. Get digits from integer before and after position. Maybe? Might as well. Well, yeah, that makes sense. Okay. Let's close all this research. And let's just go back to the problem at hand. So, easy thing to do would be to iterate over it. We could also get the length of it. Yeah, let's do that. So, I'm just going to iterate. Value over the range of uint. I could do string. Yeah, no. No. I'm just going to do over the range of uint, which is actually a really bad name because that's like a conflict, I think. But that's okay. Over the range of uint if value is equal to 49, counter is going to be 0. If it's 49, we increment our counter and we'd return our counter. Uint is not an expression on line 12. A uint, range over a uint, undefined a uint. When it's passed in on line 5, it's complaining. Oh, you know what? Got it. Is that really how they gave me the code? Oh, weird. Number. Okay. So, cannot range over number. I thought I did that though. I closed it. Cannot use number type string as uint in assignment. I need my playground back. N is equal to 10. Number Thumped print line number. Golang range over number. Golang int to binary. Int 64, string convert, int 2. Format int. Say out. No. Is equal to. Alright, these have to be our number. Int 64 is equal to. Okay, so that's the big problem. We need our number int 64 is equal to number, and then we pass our number and we range. Okay, not enough arguments, right? Okay. Two. And now the error we're getting on line 5, type uint as it cannot use number uint as int 64. I think we're just going to call it in for now. In range over in type 64 in assignment. So like Golang uint to int 64. Parse uint. No need to use string convert functions. Do type conversion to uint. Okay. So we say what? Int 64. This guy. What am I missing? There we go. Interesting. Can I use string convert to in type string? So if we bring in reflect here, we say, and we'll have to bring in thumped, and we'll say that thumped print line reflect type of in and it's just like failing hard without even printing, it seems. Is it dying here? Line 10? just create a comment block here. Okay, so that's int 64. What line is it getting very angry about? So bring back string convert, make in here, and it fails here. Reflect type of R. Undefined. Really? What is R? Oh. Interesting. Okay, so what if I were to cast that as a uint? R type string to uint. Can't do it. So what if I were to str convert a to I? That's madness. Okay. We're going to do this. So it needs to be a 64-bit integer coming into here. So we know that int 64 of number gets converted to number. Doubt it'll be happy about that. Okay. But if we just call it num and assign it, we're good. And then we can uncomment that and range over num, which is a string. And if, okay, so when we do that, then it converts it. We increment our counter, we return our counter, and we pass. Wow. But because it's a string, if we okay, it's all, the range is doing some conversion. So I index, we'll call it index, is equal to 0. Index is less than the length of num. Index plus plus. And then if num index is equal to 1, increase the counter, byte and string. What is num index? And then we will also reflect and get the type of num index. And then for now, whatever, right? Ah. Something like that. Okay. Const reflect your uints. Bytes. So can I not just say so confusing? All sorts of like types flying around here. This one is actually fairly hard for me in Go just because of the type. Like I never know what type I'm gonna get. Like I would think if I'm looking at an index of a string that I would get something, but strings are really just runes, an array of runes, and a rune is an ASCII table. And I can't convert from string to integer without going A to I. Could I do that? Could I say string convert A to I is equal to 1? No, I can't. A to I must, oh. So it'd be like if value is equal to A to I is equal to Boolean, but got found assignment. Let's just do value is equal to value underscore A is equal to string convert A to I num index, and then basically delete to equals and just say value type byte. Cannot use num index type byte as string. It's a byte, so it's a byte to oh. Okay, so Golang byte to int. Not a slice byte, just a byte, one single byte. It's an ASCII rune. Golang rune to int. Int. Okay. Problem is simpler than it looks. You convert a rune to value int with int r, but your code implies that you want the integer value out of the ASCII representation of the digit. Yes, which you can trivially get done with r minus 0 as rune or int of r minus 0. Isn't what the hell? So wait, hang on. Value is equal to minus 0. Why? I really want to figure out why that works. Why does Golang, why does this work? No, well, okay, yeah, so if you were to go here and say this, I would expect that this should work. Undefined value. This would be num at index. Right? But the thing is, I want this to come in as an integer and get converted into like basically this to me should return an integer, and it's returning a string. And if you iterate over a string and the string is all numbers, you don't end up with integers. It's just like this type conversion happening here and the different ways. And I really don't understand why this works at all. And I'd rather not have like a check against a string or a rune. I can, it's fine. There's just something that wants me, I want to keep it in integers. And I'd love not to have this string convert. But hey, let's go for you. So let's go ahead and test this out. Oops. I just got rid of my chat. It's very unfortunate. Let me see if I can bring that back. Pop this out. Okay. Something like that. All right, so we'll put this in for counting bits. Run our sample tests. Import string convert. Run again. Okay, and we'll attempt. And there you go. So we'll submit the final. Kind of curious to see if anyone at all tried to actually convert integers to binaries. Look at this. This is great. This is what I wanted. Golang math bits. Package bits implements bit counting and manipulation functions. Okay, perfect. Leading zeros, lengths. All the bitwise operations you would want to do. Cool. Well done. Everyone knows about math.bits. Now I do too. And then he just said, instead of it as a function, he just took it as bits. Top one counts. This is great, actually. It's clever. You don't have to convert into binary. They're already in binary. Well, yes, in terms that they're like bytes, but you can't see. So the kata was to count how many ones there were in the byte, right? So how many bits were flipped to 1. So what this does is, because it's already, I just didn't know that this library existed to operate on integers as bytes, basically. Is this me? Oh, this is another guy. He formatted it, and then he counted ones in there. What just happened? Oh no. I think it read your name, and it's... I gotta turn that off. Hang on. Unbelievable. Spam protection. There we go. Excess symbols. Disable. So sorry. So sorry. And then can I manage? See, that's not right. C is equal to 0 while in C plus in. Yep. Yeah, that's a lot of bitwise going on. Cool. Alright, well, it is officially 1:30. I need to head to bed. So go ahead and throw a follow on. I'm going to be doing more of these. The goal here is I am learning Go pretty much from scratch. So I'm dealing with oddities and misunderstandings as I go through these. This is probably the most rough one I've done. And I picked it because it was dealing with bits, and I knew that things were going to get weird in my understanding. So anyway, thanks for watching. See you next time, and have a good day.